This is section 3.2, and this video is actually going to be broken up into two parts because it's very long and there's a lot to cover in just one video. So this is 3.2, the first half. So we'll just say part A. All right, a lot of this section has to refer back to section 1 of chapter 2, where we had the exponent rules. So you do not need to copy down anything more for those rules unless you want to recopy it down somewhere to use. Otherwise, you can use your chapter 2 notes for this section as well. So we're just going to start jumping into some problems here. So here's the first example. Instead of regular exponents, we have fractions as exponents, and we also know that those are actually radicals, just written in a different way. So when you have the same base, we're still going to keep the base, and when you're multiplying here, you're going to add these exponents. And what I like to do, directly into my calculator, is add these two fractions together. And I'm going to walk you through one of them because it's very important to put parentheses around it. So parenthesis 1 divided by 4, parenthesis, plus parenthesis 1 divided by 2, parenthesis. And in my calculator to get 0.75, but to get the fraction back, push math, enter, enter. And I get 3/4. So that's the new exponent that I'm going to have. All right, here's another example. All right, so inside the parentheses is where we're going to start. We want to make sure, do we have the same base here? No, we have a base of a 6 and a 4, so that can't go together. So the next thing we would do is apply this 2 onto everything. And remember, we multiply. So 2 times a half and then we have 4 to the 1/3 times 2. So 1/3 times 2. And when we do the first one, again, you can put that in your calculator. Parenthesis 1 divided by 2, parenthesis, times 2, and that will actually be just a 1. So 6 to the first power, and it makes you feel comfortable, you can write the 1. And now we're going to put the little multiplication sign so we know that we're still multiplying here. And 2 times 1/3, again, put that in your calculator with parentheses around the 1/3. Hit your math, enter, enter, and you get 2/3. And unfortunately for this problem, we can't really do anything else. We don't have the same base. And so we then look at the exponent to see if we have the same radical going on here. This is a 3rd power, and this is just 1. So this is actually your answer. Now I know it looks goofy, but this is it. All right, the next problem here. Okay, so let's look inside the parentheses first. You notice how we don't have the same base here. The 4 and 3 are obviously different, but we do have the same exponent. And when you do have the same exponent, you can combine it together. So 4 times 3 is 12 to the 5th power. And we still have this fraction outside here. Now we apply the negative 1/5 to the 5 by multiplying it, and then we end up with, and again you can do this on your calculator, 5 times parenthesis negative 1 divided by 5 parenthesis, and we get negative 1. And then we have to remember, do we leave our answers with a negative exponent? No, so we have to flip this. And you can put the 1 there, but it means the same thing as 1/12. All right, the fourth example, we have 5 over 5 to the third power. We have the same base, and the exponent on the first one is a 1. So we're going to keep the base, and we're going to subtract the exponents. In your calculator, punch in 1 minus parenthesis 1 divided by 3 parenthesis. And when you do that, you should get a very long decimal. But push math, enter, enter, and you will get 2/3 in your calculator, and that is the overall answer there. Now, one thing I've noticed in the problems is that you always want to check to see, if we did this problem in our calculator and actually said 5 raised to 2/3, okay, I get 8.33333. So in this case, this would be the more simplified answer. I don't want to see a very long decimal. But in the problems that are about to come eventually here, some of these answers we can actually work all the way out. All right, here's example number 5. All right, so we work inside the parentheses first, and we notice that the bases are not the same, but the exponents are. So I can actually take 42 and divide it by 6, and that will give me just one number with that exponent. And now the last thing to do would be to multiply these two together. So we have 2 times 1/3, and that is going to be 7 to the 2/3 power. And again, check in your calculator. 7 raised to 2/3. I get 16.33333 repeating, so this is the most simplified answer that you could come up with. Okay, number 6. We have 5 to the 1/3 times 7 to the 1/4. Okay, inside the parenthesis, we do not have the same base, and we don't have the same exponent. So we really can't do anything there besides just multiply the 3 by the fractions in both of them. So now we have 5 to the, 3 times 1/3 is just 1. And now we have 7, and if you multiply 3 times 1/4, you get 3/4. And you want to look and see if you can simplify either one of those, and I will tell you right now, you cannot. So this is all done. Another one of those goofy looking answers. All right, number 7. Okay, so now we do have the same base. So we're going to keep our base here, and we're going to add 3/4 and a half together. And I'm going to use the calculator by punching in parenthesis 3 divided by 4 parenthesis plus parenthesis 1 divided by 2 parenthesis. And when you get your answer, you should get 1.25. And we're going to change that back to a fraction by hitting math, enter, enter. And so the new fraction up top would be 5/4. Check your answer. Actually punch in 2 raised to the 5/4. This is actually the overall answer. All right, number 8. Okay, so we have the same base of a 3. We're going to keep the base, but because we're dividing, we're going to subtract the exponent. So we have a 1 minus 1/4. And in the calculator, we're going to put 1 minus parenthesis 1 divided by 4. And I get 0.75. Hit math, enter, enter, and we know that It's 3 to the 3/4. And I can already tell you that there's no way this is going to have a whole answer because the 4th root of a 3, that's going to be a decimal right away. So this would be the overall answer here. And number 9. Okay, to start this problem, we want to work inside the parentheses. We first look to see, do we have the same base? Nope, 20 and 5 are totally different, but we have the same exponent. So we're going to take 20 and divide it by 5 so that we just have one number in there. And then we're going to multiply the 3 by the half. So we have 4 raised to 3 halves. Now this one is a little different because if you were to punch in your calculator, 4 raised to parenthesis 3 divided by 2 parenthesis, I actually get an answer of an 8. And let me explain to you, in a previous section we learned how to make these into radicals. Remember, the bottom is the root and the top is the exponent. So the square root of 4 is 2. And 2 to the 3rd power, it is 8. Okay, so let's start out with an example. We have number 1 here. We have the cube root of 12 times the cube root of 18. And what I would do with this one first is see if you multiply 12 and 18 together because we have the same root here. Let's see what number comes up. We have 12 times 18, and it's 216. And so what I would do is I would look to see, is there a cube root of 216? So push math, go down to number 4, and type in 216 and end your parenthesis. And I did find one, the answer is 6. So I didn't even have to break down using the tree thing at all. All right, let's look at this second example. Oops. We have the 4th root of 80 over the 4th root of 5. And again, because we're dealing with the 4th root on each one of them, let's just make this 1/4 root and divide 80 by 5. So 80 divided by 5 is 16. Okay, now the last step is to see, is there a 4th root of 16? So we're going to push 4. Math, scroll down to number 5. 16. And the answer is 2. Have a sheet to look at. So I know that the cube root of 8 is 1. The cube root of something is, I'm sorry, I don't know why I put 1. Should have been a 2 there. Cube root of something is 4. The cube root of something is 5. And so you could keep going and make your list. And the numbers that go under here, all you have to do is do 3 to the 3rd power. 4 to the 3rd power, and 5 to the 3rd power. So that's how you get your numbers underneath. So what we want to do is we want to take 135, and we're going to be breaking this down into 2 separate numbers. So let's try this 8 here. 135 divided by 8. I get a decimal, so that one doesn't work. Let's go to the next one. 135 divided by 27 is 5. So I got a whole number. So I'm gonna put 27 and 5. Because 27 times 5 is 135. Okay, now the cube root, like I said over here, of 27 is a whole number. So that is done. And the cube root of 5, you cannot break down anymore. And so there's your answer. You're going to write them right next to each other. So 3 cube root of 5 is the same as cube root of 135. move on to number 2. All right, we have the 5th root of 7 over the 5th root of 8. And I know that when I divide 7 and 8, it's a decimal. So what we need to do is to sort of rationalize the bottom to make it a whole number. And again, if you make a list of the 5th roots, this will be very helpful in determining what number you should use. Okay, so 1 to the 5th power is just 1. 2 to the 5th power is 32. And 3 to the 5th power, you can keep going on and on here. So 3 to the 5th power is 243. And I'll let you finish that. So is there something, I mean, we could multiply 8 by 1, but that really is just giving us the square root, or the 5th root of 8 down the bottom still. That's not taking care of anything. But if you look at this 8, could we multiply 8 by something to get 32? And your answer should be yes. Because 4 times 8 is 32. So if we do the 5th root of 4, remember we have to do it to the top. Now on bottom I have the 5th root of 32, which is a whole number. So the bottom just changed to 2. Now the top, because we have the same root, we're just going to multiply 7 times 4. And the 5th root of 28 cannot be broken down any farther. It would just go to these two numbers, and you can tell that neither one of them have a perfect 5th root. So 5, or the 5th root of 28 is your answer. And that's all over 2. Okay, so we have 4 square root of 10, or 4th root of 10, plus 7 4th root of 10. Okay, so now we're adding radicals together. And this is very easy if you can kind of adjust your brain. So let's think of this 4th root of 10, not as a number, but kind of like a variable. So let's just pretend that it says x. Remember, this is x. We can very easily add these two x's together, and we could get 8x, correct? Hopefully you said yes. And so we're going to do the same exact thing up here. Throw a 1 in front of here. We have 1 of these things plus 7 of these things, just like the x's. So really we have 8 of these things, and that thing just happens to be this radical. And so this is your answer. Number 2, so again, we have the same thing going on here, so treat it like a variable. 2 of these plus 10 of these is 12 of these, and those are just 8 to the 1/5. Okay, number 3. Okay, have you noticed we don't have the same thing going on here, so we can't just say 1 minus 1. But I like these problems because they kind of give you a hint of what to break this 54 down. We want something to be the same thing over here. So let's divide 54 by 2. So 54 divided by 2 is 27. So we have the cube root of 27 times the cube root of 2. And then we still have this. Now, the cube root of 27, we know from that list that we just made, is 3. So now we treat it like 3 of these minus 1 of these will make 2 of these cube root of 2's. So there's the answer. Idea of we can combine these. What is 3 times 27? The answer is 81. And then we take the fourth root of 81. You can do this in your calculator or in your head, and the answer is 3. All right, number 5. Cube root of 250 over the cube root of 2. Now, before you say, oh, well, I got to multiply this 2 by something, both top and bottom, and make it a hard problem, notice that we have the cube root on top and the cube root on bottom. Check to see if 250 can be divided by 2. And so when you do that, you should get a whole number, which is 125. Now just see if there's a cube root of 125. There is. The answer is 5. All right, we just have 2 more problems and then we're finally done with half of this section. Told you that this was very long. Okay, so number 6. We have the fifth root of 3/4. And what I'm going to do first here is I'm going to break this apart so that it looks like it's separate. And yes, we have the same root, and if you wanted to divide 3 by 4, you'd get a decimal, and that's not really how we want to handle these problems. So we need to have that list that we made already. Because we are dealing with the fifth root, we're going to make a list of the fifth root. And I'm just going through here and making this list out again, just some of the way. 3 to the 5th power was 243. Okay, now stop there because if you notice this 4, I can multiply it by a fifth root of 8 to get that one because 4 times 8 is 32. And so I'm going to multiply the top by that as well. So now the top becomes fifth root of 24. And the bottom becomes fifth root of 32. And I know that the fifth root of 32 over here has a whole number. And so now we have the fifth root of 24 over 2. And the last problem. The cube root of 5 plus the cube root of 40. So we're adding here. And again, I told you, they tell you how to break this 40 down because they give you a hint. Right here is a 5. So let's make 2 cube roots now. 40 divided by 5 is 8. So 5 and 8 make 40. Okay, now one of these has a cube root. And hopefully you can figure out which one. It is this one. The cube root of 8 is 2. Okay, so now we have 1 of these plus 2 of these makes 3 of these. Okay, so this is the first half of this section, and I told you there is a lot. But for now, what I want you to do is just start on this section and go only up to number 42. And I want to make a note that you are only doing every other even. So you start with number 4, you skip 6, you go to number 8, and you keep doing that until you reach number 42.